Welcome to qnawire.
Okay, let's see what we have here. So we know that we have an object with the mass m of 30 grams, which is 0.03 kilograms. And we know that the object is having 1 vibration per second, which means it takes 1 second for the object to complete a full cycle of vibration. So we can write it in the form of t equals to 1 second, because that's the time it takes to do 1 vibration. So then if we look for the equation that contains both t and m and k, which is the variables that we're looking to solve, you might find this one on the list of equations in the book. It's written in the form of t equals to 2 pi times the root of m over k under the root. So this is perfect for what we're going to do here, because we have t, we know m, and we're looking for k. So all we need to do is just to plug in those numbers and see what we can get. So let's try to do the calculation here. 1 second equals to 2 pi times 0.03 kilograms divided by k under the root. So if we divide both sides by 2 pi, it's going to give us 1 second over 2 pi equals to the root thing. And then we take a square of both sides. 1 second squared divided by 4 pi squared would equal to 0.03 kilograms divided by k. So that then we get rid of the root. So after that, if you do a cross multiplication, it's going to give us k times 1 second squared equals to 0.03 kilograms times 4 pi squared. Don't forget the square. So now, if we divide both sides by 1 second squared, we're going to get the k, which is 0.03 kilograms times 4 pi squared divided by second squared. That's the unit. And if you round it in the calculator, you're going to get something that's close to 1.18. That's the number. But now we have a sort of confusing unit here, kg divided by second square. You might want to ask how we can convert this into a Newton per meter, which is the standard unit we use for spring constant. Well, if you recall how we convert kg into Newton, the equation is the unit we have over there is kg times meter per second square, because that is you always do mass times the 9.8 or sometimes 10 meter per second square equals to the Newton, which is the force you have here. That's the equation. That's how we convert the mass of an object into a force, which is in the unit of Newton. So this is the unit of that equation, kg times m over second square equals to Newton. So if you divide both sides by meter, you're going to get kg per second square equals to Newton per meter. And that's what we have here. So in the end, we know that k equals to 1.18 Newton per meter. And the question also asks if we have made any assumptions throughout the process of solving this problem. Well, it is very important that you realize we did not count the mass of the spring at all during the calculation. And that is very essential, as we don't need to include that into the mass and consider how that's going to have an impact on the vibrations. So if we have to write down the assumptions we have, I'm going to say the spring is masses.